an activity for this. So I will just like explain some points for you to guide how are going to do it. So our topic for today is about the Smith chart. So when we talk about the different parameters of the transmission line, which includes the impedance, some of the SWR, the reflection coefficient, so we can derive it, or we can get the answer from our formulas, right? So we have the formulas in getting the characteristic impedance, we have the formulas in getting the SWR, we have the formulas in getting the reflection coefficient, yung diniscuss natin ng mga nakaraan. Let's say, for example, we have SWR, we have ZL over ZO, or ZO over ZL, which is uh, higher, yun yung nasa ibabaw. Then, in terms naman ng reflection coefficient, the SWR can be expressed as 1 plus R, or gamma, over 1 minus gamma. And likewise, we have reflection coefficient that would be equals to SWR minus 1 over SWR plus 1. So those are the classic methods in order to get the values of different transmission line parameters. But now, there is another way, or one way in determining these values or these parameters. So this is so-called the speed chart. Okay, so signals in a transmission line, like another medium, will behave depending upon on the characteristics and the degree of matching of the line and the load impedance. So some impedance is complex in nature that composes the real and imaginary component. Kaya meron tayong Z is equals to R plus JX, where R is the real component and X is the imaginary component. On this module, the student will understand the different characteristics of the signal and calculate different line parameters using yung tinatawag natin na Smith chart. So what is Smith chart? If we're going to define it, so Smith chart, okay, is a graphical tool, okay, graphical tool of matching transmission line impedance and the load impedance with complex impedance in it. Okay. So, ibig sabihin nun, graph, by graphical method natin siya kukunin. So i-verify lang natin kung tama yung formulas na ginagamit natin using the graphical method. So, ganun lang kasimple. So, just for you to have an idea how the impedance matching is done using Smith chart. So what are the tools needed in order for you to determine these values or parameters? So you need an Smith chart. So a Smith chart, it is a graphical piece of graphs or piece of drawings that there is values in it for SWR, for reflection coefficient, impedance of the load, and the line impedance. So you need also a colored pen or pencil. That is to identify the intersection of the curve. Ruler, so you need a straight rule for you to connect some of these points, determining the distance. And also the compass, that is to create an arc and draw a point where it connects or touches uh, curves in the Smith chart, and calculator for you to verify your calculated value and the graphical values and so on. Okay, so ganun lang yung gagawin natin ngayon, kaya madali lang naman. And also, I will be sending videos of step-by-step of getting the values, or how are you going to use the Smith chart. Kasi mahirap magpaliwanag dito sa online, kasi gusto ko man i-drawing, paano ko i-drawing. So I will be sending a reference YouTube video for you to have an idea how it is done. Okay, so but there are steps in using the Smith chart. Okay, first is you need to analyze the given characteristic impedance, your ZO, and the load impedance. So ibig sabihin, ibigay ko sa inyo yung values ng characteristic impedance of the line and the load impedance. So, given yan. Ibibigay sa inyo yan. So, possibly, I think this will be an individual work kasi for you to understand how it is done. I include this, I think, sa assignment sa laboratory. Kaya pakitingnan ang inyong canvas once I uploaded this requirement. So you need to pass it individually. Okay, so if you have a given ZO or the characteristic impedance and the load impedance, pagka meron na kayong ganyan, ibibigay sa inyo yan, you need to normalize it. How are you going to normalize the load impedance? Oh, by simply dividing to the characteristic impedance. So kung kunin mo lang yung ZL, let's say for example, yung ZL ko ay, ang ZL ko, example lang ay 75 plus, 75 plus J75 ohms. Example, ganyan. Okay? Ohms. Okay? So example, yan yung aking binigay sa inyo. 75 plus J75 ohms. And you're going to normalize it, the load impedance, by dividing the characteristic impedance. So given din yung aking characteristic impedance, let's say that would be 50 ohms. Pag sinabi nating normalize, you're going to divide lang ZL over ZO. So meaning yung 75 plus J75, i-divide mo lang yan ng 50. So what is 75 divided by 50? 1.5? 1.5 ba? Ano? 75 divided by 50? 1.5, no? So it becomes 1.5 plus J 1.5. That is the normalized value, okay, of your given ZL and ZO. Okay. Then, after mo ma-normalize yun, identify the normalized resistance and normalized reactance. So, kanina yung given natin ay ZL, di ba? Ang ZL will be R plus JX. Plus or minus JX. So, ito yung ating normal resistance and that is the normal reactance. Kapag ka-normalize natin yung ito, makukuha na natin yung ating normalized resistance, yung R prime at saka yung X prime. Ito na yon. So, in this case, on this example, the normalized resistance now is 1.5 and the normalized reactance is 1.5. Do you follow? Nasundan ba?
Sundan po.
Okay. So, once na na-divide mo na o na-normalize mo na, mayroon ka makukuha 1.5 and J 1.5. So, ito na yung ating R prime and X prime, which is the normalized resistance and reactance respectively. Okay. So, meron ka na nun. Then after that, nung makuha given na yan, you're going to locate the normalized R in the Smith chart using ruler marked with color pen. So, ibig sabihin nun, meron tayong i-graph natin yon. Note the normalized resistance axis is the line cutting the upper portion and the lower portion of the Smith chart. So, yung sa Smith chart kasi, yan, bilog yan, no? Ang ibig sabihin, yung gitna na to, ayan. Ito yung ating normalized resistance, yung x-axis, kumbaga sa ating Smith chart. Then, after mo yung normalized resistance, locate the normalized reactance. Trace it with the use of compass with color pen. Note that the positive X lies on the upper part and the normalized, the negative part is on the... So, kumbaga, meron mag-intersect na mga circle kasi yan. Yung mga circle kasi yan. Okay? Assuming sa ano mo, ito yung gagamitin mo value, ilocate mo rin yon. Okay, then padudugtungin mo yan later on. So, papakita ko sa inyo yung Smith chart mamaya. So, yun yun. So, meron siyang upper and lower din. So, ito yung aking positive R. Ito yung positive R. Ito yung negative R. Okay? Negative R prime. Then, ito yung positive X prime. Andito naman yung negative X prime. Yung pinaka-graph na yon. Okay? Kaya kailangan natin ng colored pen for you to identify the position. Then, to determine the BSWR, place one point of the compass at the center line or the resistance axis 1.0. So, nasaan yun? Yung pagka nag-graph mo na siya, ilolocate mo daw yung compass mo sa center line, itong center na to. Ito tinatawag natin na resistance 1.0. Okay? Halimbawa, ang nakuha mong graph ay mula itong point na to. So kukunin mo lang yung portion na yun. Okay, kukunin mo lang yung susukatin mo lang doon hanggang doon yung measure. Okay? And that would be your value of the BSWR. Okay. So one line extend to the compass of the intersection of normalized impedances with the radius marked along the resistance. This intersection is the BSWR value. Ngayon, without changing na compass setting, kukunin mo na ngayon yung value niya. Okay. Paano? So, pagka nakuha mo na yung saan kukunin yon? Okay. So, una natin makukuha ay value ng R. Nakikita ba? Ito yung Smith chart na tinatawag. Kung ilalaki ko to, nakikita nyo ba? Nakikita?
Medyo blurred po, sir.
Oh, ayan. Blurred talaga. Ito yung tinatawag natin na 1.0 axis. Ito yung tinatawag natin na ito, yung center natin. Yan. Yan kayo magre-reference. So, ito yung portion na to, yan, ito yung positive resistance natin. Yan, yung papunta dyan, ito yung resistance axis natin. Yan yung positive R. Then, pagka naman sa kabila, yung negative R dito. Kaya hanggang doon. So that will be the negative R. So, ito yung pinaka-center line natin. Then, mapapansin nyo, okay, mapapansin nyo dyan yung ating, may mga bilog-bilog. Kung mapapansin, maraming bilog yan, no? May mga bilog-bilog na yan. Nakita nyo ba? Mga bilog. That represents your reactance. Okay? So, meron din niyang value. Okay? So, meron niyang mga value, makikita nyo kung mga 0.5, 0.3, ilolocate nyo lang dito kung anong value niya. Okay. On this case, for example, nakakuha tayo ng 1.25. So, kung ito ay 1.0 and positive 1.25, ito ay 1.2, 1.4. So, nasa pagitan ito, 1.3 ito. Andito yung ating resistance. Okay? Ito yung ating resistance sa may point na yan. Then, kapag ka naman kinuha yung ating positive 1.5, hindi ko kasi nakikita, meron niya mga value. Okay, so ito mga bilog-bilog na to, may nakalagay din niyang 1.0, 1.2, 1.3, ganyan. Hahanapin mo lang. Assuming na nahanap mo na, let's say, ang nakuha mo ay positive 1.5, so let's say somewhere here, itong bilog na to, itong axis na to, halimbawa ito, yan. Makukuha mo yung, halimbawa ito axis na to. Yan yung belong dun sa sinasabi ng 1.2. Kukunin mo yung distance. Okay? Halimbawa, dito mo siya nakuha. So, from here to that point, kukunin mo yung distance nun. Okay? Kukunin yung distance. Okay? Yan. Doon sa may nakuha mo na yon. Yan. And then, kukunin mo yung intersection nila with the compass setting. Then, without changing the compass setting, ilagay mo siya dito sa baba. Yan. O, mapapansin nyo, okay. Hindi din makikita, no? Lakihan pa natin. Ay, wala na nakita. Ayan. Ito yung pinaka-center din niya. Then, kukunin mo yung value. Halimbawa, andito yung center mo at nakuha mo halimbawa hanggang yung ano mo na ganyan na nag-cross siya halimbawa dito. Kukunin mo yung value that represents your SWR. Meron kasi dito nakalagay ito. Makikita nyo dito, ayan. May nakalagay dyan na SWR, reflection coefficient. Ayan. Makikita nyo dyan sa axis na to. Since malabo kasi yan, yung nakuha kasing ano sa internet is malabo. Pero meron dito. Alin man dito, doon nyo kukunin yung value. So as if kung saan siya nag-cross, yun ay magiging value or reading niya. Halimbawa, ang nakuha niyang value doon ay 1.3. That is the value of the SWR on that particular. Parang ganun yung ginagawa. Okay? Ganun yung ginagawa. So, that were the steps in getting or in solving the impedances using an Smith chart. Okay. Ituloy natin iba. Ayan. So, yun, no? So, to determine the best WR, place one point of the compass at the center line or the resistance axis 1.0 and extend the leg of the compass to the point of intersection wherein the so-called denormalized resistance. Yun, meron tayong R prime and X prime. With the radius marked along the resistance axis, this intersection is the value of the BSWR. So, yung una mo makukuha is the value of the BSWR. Then, pagka nakuha na yung value, to determine naman the magnitude of the reflection coefficient, without changing the compass setting, in step 6, place one end of the compass at the center line below the Smith chart reflection coefficient. So, ibig sabihin, yung pinakita ko sa inyo nasa baba, yun din yung gagamitin nyo. Okay? Itapat mo lang siya sa tinatawag na reflection coefficient line. Then mark the end of the compass to this line. Read the value. This represents the coefficient of reflection. So yung nasa baba din kanina, yun din yung gagamitin yung compass setting. Then kung saan siya magmamark, that is the value of your reflection coefficient. Okay, and to locate the angle of reflection, kasi may angle of reflection din. Hindi na natin ito kinuha sa ating calculation, but here, you can also calculate the angle of reflection. O paano yun? So, locate the angle of reflection coefficient, make a line at the center of the resistance axis directly towards the Z reading outside the curve. This reads value of the reflection coefficient. Ngayon, saan makukita yon? Pagka nakuha mo na lahat yung value niya, yung reflection, angle of reflection can be get, nasaan yon? Andito yon, class. Okay. Ito, may mga angle dyan. May makikita nyo yung mga angle dito. Ayan, yung mga angle dyan. Diyan nyo siya makikita. Yun yung karagdagang info na i-graph natin once na nag-graph mo na ang BSWR, the reflection coefficient, and if you want to get the angle, i-extend mo lang yung graph mo, and from the extension, makikita mo dito yung value. So medyo malabo kasi, may mga number yan. So ang angle is measuring from, let's say, 0 to 180 degrees. So makikita nyo dan yung value ng ating reflection coefficient. Okay? So nasusundan ba? O mahirap? Mas maganda siguro makita nyo sa YouTube video, no? So kung sa YouTube video naman, para makita nyo lang, okay? So pag-aralan nyo ito, so these are the sample problem. Prepare, locate, determine the transmission line parameters, normalized impedance, BSWR, reflection coefficient, for the following. So ito yung sinasabi ko sa inyo, ibibigay ko sa inyo yung mga values. Okay? Then, pagka nakuha nyo na using sa Smith chart, i-verify mo siya using the algebraic method, yung solving natin na ginagawa. Okay, yung formula natin na ginagawa na SWR is equals to ZL over ZO, or pwede din namang 1 plus reflection coefficient over 1 minus reflection coefficient. Then yung reflection coefficient mo will be SWR minus 1 over SWR plus 1. Verify nyo using this formula yung mga nakuha nyo. So, dapat ang makuha nyo value ay malapit or equal doon sa makukuha nyo sa Smith chart. Did you get it? Nasundan ba?
Yes, sir.
Okay, then, para maintindihan nyo talaga yung sinasabi ko, okay, bisitahin nyo yung mga link na to. Yan, sa YouTube. Mas maintindihan nyo siya kung paano ginagawa. I don't know kung makakapag-share ko ng video. Makakapag-share ba ito sa yung sa Google Meet ng YouTube video? Or panoorin nyo na lang? Anyone? Any idea na makakapag-share
Pwede
ba?
po ata, sir. Naka-share screen naman po kayo.
Sige, tingnan natin. Unshare ko lang Stop sharing. Okay. Kaso, naka-PDF ito. Okay, so kukunin ko lang sa isa yung anyway, pwede naman ako. Okay, stop presenting. Then, magano lang ko ng YouTube link, SWR, Smith chart. Sa YouTube. Smith chart. Ito yung ginamit ko. Yung Smith chart, part 1 basic. Sana ba? Okay. Share ko lang. Share screen. Hindi pwede. Share. Ano siya? Windows siguro. Hindi pwede. Ayan. Nakikita na? Ha?
Opo, sir. Nakikita na.
Ayan. Ito yung gagamitin yung tutorial, yung Smith chart basic part 1. Allow video play. May
We're
audio
going to talk
ba?
about the basics of the Smith chart. So first of all, the Smith chart is this. It looks scary and intimidating, but really what it is, it's a way of graphically determining transmission line parameters much more easily than you would do it mathematically. So the Smith chart is your friend. So here, if you imagine a transmission line, you've got, this is the generator, and this whole thing is the transmission line, and this is the load. So you think about it, a typical setup, you'd have a radio transmitter, coaxial cable connecting to the antenna, generator, transmission line, load. So if you want to know whether or not your or how well matched your load impedance is to the rest of the line, you can use the Smith chart to do that. Impedance is a complex number. There's R, that's the real part of the complex number, and X is the imaginary part. Okay, and you can plot impedance on a Smith chart by finding the real part and then finding the imaginary part, and where they intersect, that's the impedance on the Smith chart. And once you have the plotted Smith chart, the plotted impedance, then you can find things like VSWR, voltage standing wave ratio, reflection coefficient, and other things as well. So here's how you do it. You normalize, you find the normalized resistive part, you find the normalized reactive part, the real part, and the imaginary part, and then you plot a point where they meet. So I'll show you how to do that. So here's my Smith chart. I'll say plotting impedance. So example. Let's see. Example. Let's say load impedance equals 50 plus J 50 ohms, and the characteristic impedance of the transmission line is 50 ohms. Let's try that. Okay, so this is the load, and this is the line impedance. We want to see how well of an impedance match this is. So here we go. So here's plotting Z. The first step is we normalize. So we divide by characteristic impedance. So we just go like this. All right? Because characteristic impedance is 50, so that ends up to be 1 plus J1. So I can say that load impedance normalized is equal to 1 plus J1. So step 1 is done. Step 1 is done. Step 2, we find normalized R on the chart. Well, I have to show you a few things about this. Here's the Smith chart. The R are the numbers along here. And the X are the numbers along here and down here. So if the step is, if we have to find the normalized R, what did we work that out to be? That's 1. So this is the normalized R. This one is the normalized X. So finding the normalized R, which is 1, I go along here. These are the R values. 1 is right here. Okay, so that's 1. That means everywhere on this line that passes through 1, that's a normalized R of 1 on that circle. So we could say anywhere on this circle, normalized R equals 1.
So that is the 1.0 center line axis.
Next step is find normalized X on the chart. Well, that's these numbers here. And since it's plus JX, it's going to be the top half. If it was minus JX, it would be the bottom half. So I go along here, there's 0.1, 0.2, 0.3, 0.4, I look and I see 1. There's 1. So everywhere along this semicircle, okay, so that's in the wrong place. Normalized R equals 1 is everywhere on this circle, and normalized X equals 1 plus 1 is everywhere on here.
So the point of intersection, that is
And
that
the next
impedance.
step, so we have the normalized R
SWR.
of 1 and the normalized X of 1. Where they cross, you can call that load impedance. So we just plotted, so normalized impedance is 1 plus J1, and you could say the impedance is 50 plus J50 ohms. That's 50 plus J50 ohms plotted right there. So that's plotting impedance. So do one more, and then you will be an expert. So load impedance is equal to 300 minus J.
It's another example.
Ohms. And you can say if Z naught, which is the characteristic impedance, is equal to 50 ohms, the normalized impedance is going to be 300 over 50 minus J 25 over 50. And that's going to be 300 divided by 50. What's that? 300 divided by 50? 6. 6 minus J 25 over 50. I think you know what this is. 0.5. Okay, it's J 0.5. So we were looking for 6 minus J 0.5. This one is the normalized resistance. This is the normalized reactance. We have to find this first, and there will be a circle associated with that. We find this, there will be a semicircle associated with that, where they cross. So you have the circle, and then you have the semicircle where they cross. That will be the load impedance, just like before. So we'll get a new one. New Smith chart, 6 minus J 0.5. So here we go. So what is our Z equals 300 minus J 25 ohms, and characteristic impedance of 50 ohms. So 6. So remember the resistive part is along here. Normalized resistance is 6. That's 3, 4, 5. This happens to be 6 right here. That means this circle is the circle of normalized R equals 6. And then we want minus J 0.5. So these are the numbers for reactance. 0.5 is here. So I just trace that semicircle up here. The numbers are also here. They're the same numbers. Keep going, keep going. And we keep going, we keep going, we keep going, we keep going. That is going to be the load impedance right there. A load impedance of 300 minus J25 on a 50 ohm line. So that's how you plot impedance on a Smith chart.
Okay.
Grammarly does more than catch errors. With Grammarly,
Okay. Nasundan?
Nasundan naman po, sir.
Okay, so meron pa yung part 2 tsaka part 3. Yun yung pagkuha nung kung paano ipa-plot yung sa compass. So, yun yung panoorin yung video, no? Mas malino kasi yun kaysa sa ibang Indian. So as is, ganun lang yung gagawin niya. So, get first the normalized value, plot it. Meron dong mga number. Mas maganda i-plot nyo ng malinaw. Kasi kailangan nyo ng, i-graph nyo kasi yan. Kailangan nyo i-print ng malinaw yung Smith chart. So, meron po yun ng magandang malinaw na Smith chart sa web. Okay, and then, all the values will be verified using the formulas na presented sa inyo before. So, dapat ang maging sagot nyo doon, equals or mas malapit doon sa value na kinuha nyo. Okay? So, individually, so siguro, ako pa ba magbibigay ng, sa laboratory nyo kasi, meron yan. So, siguro kanya-kanya na lang din na given kung gusto nyo. And then, present one Smith chart for your selected impedances. Okay, so I think that's it for today. Okay, so if you want to get the detailed procedure for the SWR using the compass, so try to continue viewing that video. So the particular video, Smith chart basic, and then you will learn it from that. Kasi mahirap magpaliwanag dito, kaya kumuha na ako ng katulong. So nag-recruit ako ng yung Amerikano kong kaibigan sa US. Ayun. Kaya siya muna pinagturo ko sa inyo. Okay? So important yung nagturo sa inyo ngayon. Okay, question. So far. So kung wala nang tanong, that's end of our lesson for today. So that is a part of your laboratory. Kasi ng transmission line yan. So that ends the topic for the transmission line. And the next topic will be waveguides. And after waveguides, we will tackling about antennas. So, and after that, if we have time, we could tackle fiber optics. Okay, question so far? So kung wala nang tanong, kindly open your cameras.